Yeah, hello everyone, and welcome after the lunch break. I hope everyone have enough time to grab something, so my picture is not looking so painful for you. So my name is Kateryna, and I'm a software engineer in data and machine learning in the data part specifically, department at Delivery Hero. And our topic today is hybrid cloud data streaming architecture. And what I would like to tell you is on the example of our company, how we design our data streaming pipeline, how we build it step by step, and why we choose in the end to have a hybrid cloud solution. So in order to understand why we build such an architecture, you will need to know a bit about our company and the data that we are operating. So first of all, I have a question to the audience. Is there any people in the room who never order food online? Still some people. Okay, maybe you'll start. So once again, my company is called Delivery Hero, and we are a leading online food ordering service and delivery marketplace. So our headquarters is located in Berlin, Germany, але сама я з Харкова, тому мені дуже приємно тут бути і дякую організаторам. Всім привіт. Let's switch back. So the company was founded in 2011, and today we are working in more than 40 countries around the globe. And we have a large chain of the restaurants that working with us is like more than 200,000 different restaurants, and we also deliver not food only, but some groceries, flowers, and etc. In 2017, we went for the IPO. I mean, we successfully went to the IPO. And in the first quarter of 2018, we have 1 million orders per day. And a few months ago, in July this year, we hit a power of 2 million orders. So you can imagine that we have a lot of data inside the company. If we are talking in numbers, I can say that we have like roughly 10 million order-related data per day. What does it mean, order-related? So it's like orders itself and some information about the changes of the order statuses. Plus to this number, we have user keys. You can imagine it's like a huge amount. Logistics data, which is data from our drivers who deliver the food. Restaurants, updates, some menu items, some products, some customer data. So, a lot of data. And another important thing to know about our company is that we have a concept that's called House of Brands. What does it mean? House of Brands means that company itself is not promoted. So you will not be able to find the Delivery Hero delivery, but you will be able to order food at eFood in Greece, at Aqua in Egypt, at Yum in Austria, and so on. So we have a lot of brands under the same roof of our company. It has a number of benefits, such as, for example, we have localized and broad experience. And also, since we acquire a lot of the companies, they are already well known, and we don't need to start the market from the scratch. Yeah, we are back. But also we have a number of challenges, and this is what I would like to focus more in this talk. So how it's worked before. We have some of the data producers on the left-hand side. So this is our brands that are actually small companies in different countries. It means that they are not connected, and also they are completely different in terms of IT stack. So they have different API, different data representation, and so on. And on the other hand, we have a number of backend services, such as search, logistics, some recommendation systems. And we provide a solution to all of our brands. So how it was at the beginning, if, for example, Foodpanda is our major brand in Asia, if they want to have search and logistic capabilities, they need to write connectors for it. The same for Kateryna, the brand from South America. If they want to have all of them, a lot of connectors. Talabat is a brand from Dubai, another connectors, and so on. So you see that we have a lot of unneeded connections that we need to design, maintain, and so on. And imagine that you are kind of a new brand, and you want to have all of these capabilities, so this is very prioritized task for you. But from the part of the data consumers, it's just another OKR or another task in the list. So like priorities are different from different sites. So that's why my team was invented. We are called Data Fridge, and we are standing right in the middle between data producers and data consumers in order to provide for them a standardized data pipeline. And to do so, we need to solve next questions. First of all, we need to define how to unify the data structure across the company. So as I mentioned before, all of the brands have different API and different data representations. So order in one company will look completely different in another company in terms of name of the fields, mandatory fields, and so on. And we need, in order to use this data somehow in a big quantities, we need to unify it. Secondly, we need to provide different data access. So some of the data consumers need to get data as fast as possible and then process on their behalf. Some of them are interested in the low latency API, which is like relevant data for latest months or some specific orders. And some, such as analytics and ML teams, they need to have access to the historical data. And more, we need to become data producers for the machine learning teams, since they need not only to get the historical data, but also get the relevant data in order to have proper predictions. And so you know enough to get a look to our architecture, and we will cover step by step how we implement it. So in the simplified form, once again, here are our data producers, and this is Data Fridge. So the first entry point to the system is the ingestion API. The two main goals of the ingestion API, first of all, is to check that this entity is authorized to send the data to the system, and secondly, to verify that data that it sends is according to our data models. The second point is the data streaming. This is the core of the platform, and it's used to distribute data. And after that, we provide event subscriptions. So we keep all of the events in the system separately. So we have a separate stream or treat for orders, separate for vendors, separate for products. And here is our first use case. We have subscriptions to the near real-time data. Apart from that, we have a low latency APIs that is used for reporting and some additional things. And here is our second use case. And the third one is long-term storage and access for data analysts and machine learning teams. So let's have a closer look step by step. And the first one is the ingestion API. So when we start the project, we have a big question: how to validate import from different data producers. And so what we did, we created a SDK which contains all of the data models. They are used to verify data quality in Data Fridge, but also integrated in all of other teams in the company. And so how we actually define the schema for all of the data producers, it was a long process with communication between all of the data producers and data consumers in order to define all of the mandatory fields. So now we have a fixed data model, and in terms if we have any new brands acquired, we just add some additional fields to the schema. And part of our system is deployed on the AWS, but we also have a big part in the Google Cloud. We will cover it soon. But in terms of ingestion API, under the hood is just an API gateway with Lambda that is called each time we have a new request to the ingestion API. We also provide endpoints for the batch import. It's used in case we need to import some historical data. For example, if we have a new integration with a new service, and so you need to transfer to our data lake all of the data. In terms of security, we have pivot listing and shareability authentication, and the biggest learning here for us was the data quality. So how our system is designed, if we have any invalid events, we send them, so we reject them. And they're supposed to be retried and modified on the behalf of the data producers. But in the reality, not all of the data producers can support such retries. So they just send us the same data with the same issues. So what we did, we store all of our embedded requests to the long-term storage without PI data, of course. And then we can create some reports or visualization for the separate teams. And then with this information, we can go to teams and solve the main data issues. And if we are talking about deployment, so if we have any changes to this data validation, even though we have tests, it could be that it will harm our system. So for that, we need to define the way how we can safely deploy the new versions. And for that, we use the canary deployment. So for those of you who is not very familiar with it, it's similar to the green and blue deployment, when you have just two versions and you switch traffic from one to another, and if needed, you switch back. But in terms of canary deployment, you have two versions and you just switch traffic piece by piece by checking the health of the system meanwhile. So how it's done on the AWS, first of all, you need to have versions of your Lambda code, and then you should have an alias, which is the pointer to the version that is used, for example, on production now. And what you did, you just, in our case, we have it just in a script in Travis, but also I know that there is a way how to do it from the code deploy. So you just increase the amount of traffic to a new version and check all of the alarm metrics for this Lambda. And after all of the events were ingested by ingestion API, we get to the stream part. And for the streaming, VR uses AWS Kinesis, which is similar to Apache Kafka that you may know. So we have a separate stream for different event types, and here we can store data up to 7 days. And why it's very important, first of all, because if any part of our data pipeline will be broken, so we have enough time to recover. Another good feature here is ability to replay data, because Kinesis supports reading with offset, so we can replay data for some specific period of time for any of our data consumers if it's needed for them. And how it works? Yeah, we have just Kinesis and another Lambda that after that publish data to the SNS. And here we come to our first use case, which is near real-time streaming. We calculate the SLI from our system, and in terms of latency, from the moment when event was ingested in the ingestion API till the moment it gets to the long-term storage, which we'll cover soon, we have 1.2 milliseconds. So this data is accessible through two types of subscriptions. One is HTTPS and one is SQS, which is simple queue from AWS. Also, we provide data aggregation, so it means that we provide order, for example, with all of the order statuses that is related to this order. And another good thing here is that we have a filtering. So we can provide access, for example, for the data consumers, but only for the countries where they are working in, or, for example, name of the brands that they are part of. And the next point is the low latency API. Behind the scene, low latency API uses the same near real-time subscription, and the main block here is DynamoDB. So we store events to the DynamoDB, and then we have an API gateway to access to them. Of course, we store all of the personal data for 30 days in order to be GDPR compliant. And the biggest learning here was to use dead letter queues, because we had situations when we have spikes in our data load, and DynamoDB was not reachable for some time. And that's how we were losing events. So using dead letter queues become a salvation for us, because there we will try to publish to the DynamoDB, and then if after several tries we failed, we can just store everything in the dead letter queue, and then we have up to 14 days, I guess, to recover this data. And the last point, we finally got to the point when we have this hybrid cloud solution. This is analytics. So analytics is used, of course, for the analytic teams and machine learning teams. And when we start working on this, it was hard for us to decide which tool to use. because there are so many on the market that are lookalike. But then we start communicating with our stakeholders, with our data consumers, and it appears that like most of the analytic teams in our company are already using BigQuery. So it was a clear solution for us to start using BigQuery as well. And here we have another question, how to transfer data from the AWS to the Google Cloud. And first we start using PubSub plus Dataflow, but it appears to be a very costly solution. And when we cut it in favor of just using Google Query Streaming API, we saved up to 80% of our monthly spends. So a big learning here, yeah, don't have our mistakes and use data flow in places where it's not needed. So how it works now, we have a Lambda on the part of the AWS, and we have Datacentric for the same purpose we have it for the DynamoDB, and we called directly Google BigQuery in order to preserve the data there. So we are GDPR compliant here because we can remove all of the personal data by request. And also we provide different kind of access by creating different data views for teams with the filters by the same country or name of the brands and so on. And we use a lot data visualization tools to provide some view on our data. And here is everything one more time, layer by layer. And here two main learnings for us was, first of all, there are a lot of similar tools on the market, so it's up to you which one to pick. And you should not be like strict to one data cloud provider. So mixed different approaches appears to be very simple task. And then secondly, we were trying to use like out-of-the-box solutions as much as we can, and it was very beneficial for us. So using Kinesis instead of Kafka was totally cool for us. And in terms of the tech stack, as I mentioned, we have like both AWS and the Google Cloud. From the Google Cloud, we use BigQuery. We use PubSub with Dataflow previously. From the Amazon, we have SNS, SQS, DynamoDB, and we have Lambdas as our like main built-in block for the code. We have it in both Java and TypeScript. For the monitoring, we use CloudWatch, X-Ray, Looker a bit. And in terms of infrastructure, in our team we have a rule that all of the data engineers are also responsible for the DevOps. So we have our whole infrastructure automated through the Terraform. And recently we started using Atlantis, which is a service that allows you to deploy Terraform remotely from the GitHub pull request. So if you're also using Terraform and you have like multiple people who are working on it, you should check this out. And one more tool that we started using recently is Apache Atlas, and this is the data catalog solution, and this I want to cover a bit more. So data catalog is just a metadata service for the governments. So basically it's just a storage where you keep all of the metadata from your data. And why it's important, first of all for us, since we are already the source of truth for some types of events, but we are not covering 100% yet. And also, we have a lot of different teams in the company, and some of the data is produced and used inside the team. So teams are not aware what kind of information is available in the company. And the probability that it actually can be reused is very, very high. That's why creating the data catalog and make it visible for everybody which kind of data is there in the company is very important for us. So here we actually have the same type of the question, which data catalog to use. We were checking AWS Glue, the new release from the Google, and also solutions from Netflix and LinkedIn. But it was two features that were crucial for us, and we find them implemented well only in Lineage, only for Apache Atlas. And this is lineage and ability to visualize relations between data models. Also, using Apache Atlas, we are not, so we shouldn't use only AWS or the Google Cloud, so we can combine both solutions. One minus here is that Apache Atlas is not SaaS solution, so we still need to deploy it together with Solar and together with Cassandra, but it's totally doable. Yeah, and this is actually it in terms of the data catalog. And in the end, the last thing that I want to mention is what we have now and what we want to cover in the future. So we are on the way of becoming data-centric team or company. By that I mean that we need to use data not as an asset, but as a main engine for all of the processes and technologies that we have in the company. To do so, we need to create a data-centric architecture. So it's not enough just to validate the data and transfer it to some users. We need to track the quality and governance, and also we should take care that the metadata of the data is actually used. So this is what we have now in terms of technologies. So you can see that we pretty cover ingestion, transport, and access paths, and also we have this new catalog solution. And in terms of the quality, yes, we have this work with invalid data, but still a lot need to be improved here. And also in terms of data governance, we need to make sure, for example, if we have order status, we will receive order with this order ID in some time data. If this is not happening, our data is not complete, and we need to be notified about it. Also in terms of the data science, we have data science teams in the different departments in the company, but here we have a lot more to do, since we have a new, transparent, clean way how to access the data. And this is all from my side. Thank you so much for listening. I will be happy to answer all of the questions. And two more things that I need to mention. First of all, we are hiring. So please go and check our open position, but we are especially interested in data scientists and data engineers. And secondly, we will have another talk from our company tomorrow at 10:55. It will be ahead of our data and machine learning department, so it will be very interesting, and see you there.
Hi, thank you for your presentation. So my question was, how regulated is the data sector in EU countries since the GDPR was implemented? And what are the possible restrictions if going up to the European market would be there to challenge the enterprise in terms of data science and data collection?
Yeah, so of course currently everyone in the European Union needs to take care about the GDPR, and in our company we are aware about it, and we provide that if we have any user's request, we will need to remove all of the data in the 30 days, and we're actually doing so. But in my point of view, and it's anyway manageable, you can somehow like randomize data or like keep all of the customer data separately. So yeah, it should be totally possible to have a proper data science solutions, even with these restrictions.
Thank you.
Hi. Sorry, it was a stupid question, but why you need a catalog and what is it?
Okay, so once again, data catalog is just a kind of like database which store all of the metadata about your data. It's like actually as data models or data schema. So you save all of the data schemas across of your company, and like any developer can access it and see what data you're operating with. It could be very cool for the data scientists, for example. So they will have abilities to improve their data sets, and also this is a solution to not to duplicate the same work, because some of the teams can start working on something, and then another one, and you just like spend time on doing the same job.
Thank you for a quite interesting presentation, and this is a very good example of using serverless architecture in AWS. And my question is, what is the reason of using serverless approach instead of a classical approach with much Kafka, with EC2, for example, or even Elastic Beanstalk?
Yeah, we don't use any EC2. All of our code is deployed on Lambda. Maybe it's specifically because of our use case, but because what we're doing, we just like validate the data or somehow transform it. So we don't need to store the state. And also Lambdas are very good scaled, so you don't need to have a Kubernetes cluster. It will scale automatically depending on the load. So for example, here we have a huge load on the part which is sending data from AWS to the Google Cloud. And even so, we never faced any bottleneck here because it's scaled in the terms of the amount of the data you have.
One question, how much data do you receive during one day?
So,
Data ingestion.
as I mentioned, we have like 10 million order-related events. We also have like, I don't know, up to like 4 million for the products and vendor updates. And this number is increasing because we are not very old team, and so the integration is still under the process. So yeah, it will be much more in the nearest months.
Thank you.
Есть ли еще вопросы?
Can you please tell a bit more the model of consumers actually access data? Is there some kind of views that they can go through and query the data lake, or how it happened in your case?
Yeah, since we are responsible for this data, and we need to make sure that since we have a like full data for all of the brands, we need to make sure that we have a separated access for different teams. So how it works now, we have a process inside the team that you can apply for data access, and then we will create SNS subscriptions, or we'll create a separate view in the BigQuery with only data this team can access to.
Thank you. So there is no duplication, right?
So what,
There is no duplication in data. I mean, one consumer.
Yeah, it's just different types of the access to the data, just visual views.
Thank you.
Here we go. More stupid question. Do you use custom data centers, or you have only everything on the cloud?
Yeah, we are complete on the cloud.
Why?
Because teams are distributed across the world, so it's much.
So you just don't need it.
Yeah.
Thanks.
Есть еще вопросы?
So you said you have API data. How you work with it? You tokenize or encrypt it for your
API to the data?
PI
data. Okay, yes.
How you figure out is it so you tokenize it or use some other encryption tools?
So at the moment it's stored in the different kind of the data storages, as I mentioned, and we have access which is like secured by JWT tokens. So if you grant you this token, it should be allowed to you to see this user data.
Есть еще вопросы?
I guess this will be the one last question for me. My question is just to make sure so that I understand how this whole thing works. So you do have some tracking software embedded to the applications, right? Which collects the information regarding the choices and regarding the basically actions taken, which were taken from different customers. That way.
You mean the user clicks data?
Yeah.
Yeah, we have it in the company.
And so you will receive all the information by this way, right? Like from the interface.
Oh, I'm sorry, I think I will not be able to answer you exactly because I'm working on the streaming part, yeah.
I see. All right, thank you.
Есть еще вопросы? У нас еще есть время, мы можем что-то обсудить, рассказать. Нет, да, вопросов?
So the thing is that they collected the order data from the backends of our platforms, and you were talking about the Clickstream, and from Clickstream we use Google Analytics, and we export Google Analytics data in BigQuery. So this solution is used mostly for the transactional data.
Хорошо, спасибо, Катерина, большое.